Hi everyone, we will continue learning Raspberry Pi Pico, and today we will use GPS receiver to get our location. These are required components for today: Raspberry Pi Pico, 4 jumper wires, and GPS receiver. We will use u-blox Neo 6M in this example. And then optionally we will use also OLED display, which already used on our previous videos. Video number 5, number 6, for example. This is the GPS hardware. It consists of 2 parts actually. This one is the receiver itself. It has 4 pins here: ground, TX, RX, and VCC. And this one on the right side is its antenna. We could see here that the GPS receiver is connected to this antenna using this black cable here. On our setup here, this ground pin will be connected into this ground line. VCC will connect to 3.3 volts here. TX pin will connect into RX on the Raspberry Pi Pico. We will connect it to the second pin, or GP1 here. This GPS receiver communicates with our Raspberry Pi Pico using UART communication protocol here. So this TX pin will connect into the RX pin of Raspberry Pi Pico. This one. The second pin here could be used as the RX pin. And the RX pin of this GPS receiver will connect into the TX pin of Raspberry Pi Pico here. Pin number 1. The real mandatory cable is actually only one, this green one, because it will transmit the message from GPS receiver into our Raspberry Pi Pico, and we will only listen to it. We actually don't want to transfer back anything to this GPS receiver from our Raspberry Pi Pico. We will just listen to it. And so this transmit cable, the green one, is actually the only one necessary. Here's our setup here. TX pin of the GPS receiver connects to RX pin here on Raspberry Pi Pico, and RX pin on the GPS receiver connects to TX pin on Raspberry Pi Pico. In this workshop we will also use OLED display like before. This one, and it will connect through 4 wires. Ground pin of OLED will connect into ground line here, and VCC will connect into VCC 3.3 volt here. SDA pin will connect into this pin. Let's take a look here. Pin number 21 here can be used as SDA pin, so we will connect the SDA pin of the OLED display into this pin, and SCL pin will connect into this 22nd pin here, because it can be used as the SCL pin. So that's the complete wiring for today's workshop. One more thing we have to know when we're using GPS receiver is this NMEA sentence, because this GPS receiver will communicate through our Raspberry Pi Pico using this sentence. Let's take a look what is NMEA sentence. Basically, when GPS receiver connects into our Raspberry Pi Pico, then it will continuously sending those informations. One of the most important thing, of course, global position, which will be delivered using this GPGGA message. Let's take a look here. This is the example of GPGGA message. The first one is sentence identifier, $sign followed by GPGGA here, then time, and then latitude and longitude, represented by 2 parts here. The first part is a numeric part, and the second part is the character, and then longitude also represented with 2 parts here, and mean north on the latitude, and S means south. On the longitude data, W means west part and E means east part, followed by fixed quality, and then followed by number of satellites, and followed also by HDOP data. HDOP indicating the horizontal position accuracy. The lower the HDOP value means the higher position accuracy. And then next is altitude data on meters. We will work this GPGGA data to obtain latitude, longitude, and also number of satellites, GDOP value, and also altitude. Next we will use in this workshop is GPRMC format here. GPRMC consists of also latitude and longitude with addition of speed and course. Speed in knots and course in degrees. It will be useful if we use this GPS receiver for vehicle tracking, for example. We will continue to the code right now. Here is the basic code that we will use. Please note here that from machine we will import UART, which will be used to communicate with GPS receiver. We also will use OLED display, so we also need to import I2C and also import this library. Remember that we will need this SSD 1306 library to use this type of OLED display. Next, we will initialize the GPS object here. It will be a UART object. ID is 0. Then we will use baud rate 9600 here. We will use TX pin GP0, and we will use RX pin GP1. Then followed by the OLED initialization here. We will use the same configuration as our previous video, except this SDA and SCL pin. The SCL pin will connect into the GP17 here, and SDA pin will connect into GP16 here. Now we will try to initialize the OLED display with this command, and we will enter the loop. We'll use this variable buff. Buff is actually global variable which we already defined here, and we will use it here. Buff will be a string buffer which will be filled with the data coming from the GPS receiver. We will use readline function here, which will be used to receive an MEA sentence from the GPS receiver. We will just simply print out the buff content here, and it will be repeated continuously with 200 milliseconds delay. So we will run this code now. Here we can see all the NMEA sentence that are available on this GPS receiver. There are so many information that we actually may be not needed for now. We will filter NMEA sentence which only GPGGA and GPRMC sentence. Here we will filter the message with this command. So we will only print GPGGA and GPRMC sentence here. Let's run the code like this. Everything else will be omitted here. Please note that this OLED display is working correctly. We can see this text coming out from this OLED display, and also GPS receiver is okay. We can see some data here on GPRMC and GPGGA and MEA sentence. So this code is working correctly as expected. There are still some things to be done here. The first one is we need to parse the NMEA sentence, right? So we will create a new function to parse the NMEA sentence. We will name it parse GPS function, and it will receive the sentence. the NMEA sentence. The idea is we will return the dictionary of GPS data. The dictionary is like this. The GPS data almost always have latitude and longitude data, and also those optional information. For example, if we use GGA, then we will get latitude, longitude, number of satellites, GPS time, HDOIP, and altitude, but not speed and course. And otherwise, if we use GPRMC data, then we will get latitude, longitude. We will not get the number of satellites visible, but we will get speed and course if we use GPRMC. So basically this dictionary will hold all the GPS data, either that is mandatory or optional, and we will initialize everything here with none, and then we will split the sentence using comma, because NMEA sentence is separated by comma. We could see here again. It consists of several fields which is separated by a comma. Then we will only listen here into NMEA, GPGGA, and GPRMC data. We will use this code. If the first part is GPGGA or the first part is GPRMC, then we will proceed processing the NMEA sentence. Otherwise, we will omit that. And then at the end of this function, only if longitude and latitude data is available, then we will return this GPS data. Now take a look at this. We need some tools here, because to obtain latitude data, then we will translate this part 2 and part 3. Let's go back again to GPGGA format here. This is the first part, second part, and third and fourth part here will be translated into latitude information. So here basically we will send this information into the 2-degree function. 2-degree function, we will create it. Here it is. This function basically transform NMEA latitude, longitude data into decimal degree latitude or longitude. In NMEA sentence, for example, 12345.6789 and S and W for longitude data. This is just an example. Then it will be translated into 123 degree plus 45.6789 minute, which also means it will be transformed into 123 degrees plus 45.6789 divided by 60, all other degrees here. So this is what actually done in this function. And then we will also need two float function here, and the two float function is just converting text into the decimal number here. This is the actual conversion, but we will wrap this with try except, because in case anything going wrong with this string to float conversion, then we will get none. Then next, we also want to use toTime conversion tool and toDate. These are the functions. This one is just converting, for example, 10, 25, 16 into 10, 25, 16. So these are what actually done inside these functions. To float will be used to convert string to float, return none if error happens, for example, invalid floating point number value. After all of this, then we can send this buffer into this function, parse GPS, and the return value will be stored, for example, in data variable here, parse GPS sendBuff as sentence, and then we could print return data here. It will simply print out what the content of the dictionary. But besides printing this dictionary data, then we also want the result to be displayed on our OLED display. So we will add another function here. We will name it OLED print data, and we will pass data into this function. And this is OLED print data function. We will receive GPS data dictionary as D variable here. We will use 5 lines of OLED display as we discussed in previous video number 5. So because the first line will be the title, then we will have only 4 lines text to be printed in our OLED display here. And we will name it variable S1, S2, S3, and S4, which will be printed on the first, second, third, and fourth line respectively. Please see here, we will only print data if only the longitude and latitude information is valid and not empty. So we will only execute this if the longitude and the latitude is correct. Then we will fill the first line of string with information of latitude and longitude, and then with this sentence, if altitude information is available, then we will put it on the second line. If HDOP and number of satellite information is available, then we will put it on the third line. If GPS time is available, then we will put it on the fourth line. And otherwise, if speed information exists here, which means the information coming from the RMC NMEA sentence, then we will have speed on a second line, and course or direction in third line, and we will also add timestamp into the fourth line. Then we will need another function to directly print first line of message, second line of message, third line of message, and fourth line of message into our OLED display. And we will create a function here. The function will name OLED print rows. S1, S2, S3, and S4. This is what will be done in this function. First, fill all the pixels with 0, Then we will add a title in the very first line and add 4 lines of information in the following lines. We have to make sure here that we will print data only if data is available. If data is available, then we will print out the data and also send it to the OLED display. We will check again our code before running it. First, we'll parse the buffer, put it on a data variable, and then if data is available, is okay, is valid, then we will print the data and also display on the OLED display here with this OLED print data. This one is OLED print data, and from this function we will send 4 lines of string here. Otherwise, we will send no GPS data into our OLED display. OLED print 4 rows function is here. It should be OLED print 4 rows function. Basically, it will only display those 4 lines of text here. I think everything should be fine right now. We will try to run this code now. We can see here the GPS information. At the first line, it displays latitude and longitude. Then on the second line, if we got data from the GGA data, then it will display Z, altitude, HDOP, number of satellite visible, and time. Instead, if we get data from the GPRMC sentence, then it will display speed, course, and also date here. So our code running as expected. That's it for today. Thanks for watching.